Welcome students. We come to the concept of vector and scalar. This is quite well known that scalar, the word scalar comes from the word scale. Now a vector, as we all know, have two quantities. One is the magnitude and the other is the direction. So it is a quantity which contains magnitude and direction. Now for a scalar quantity, you say that it is only having a property of a direction, do not have a property of a direction, it only have a property of a magnitude. So a scalar has to do only with the magnitude, while a vector has to do with both this magnitude and direction. But at this point of time, we come to know that this definition of a vector or a scalar is not enough. So we come to another property which should be attributed to a vector, is that it should follow the vector algebra. So this is one very important property, that it should follow the vector algebra which consists of addition, which consists of subtraction, and which consists of multiplication. Now a vector cannot be divided simply because of the fact that direction cannot be divided. So there is no division involved in vector, as because a direction cannot be divided. So now if we come to some examples of vector and scalar, then there are two very examples, like I would say current electricity, or say electrical current. Now electrical current have both magnitude and direction. It has both magnitude and direction. But yet it is not a vector, simply because of the fact that it do not follow the vector algebra. So current, in spite of having magnitude and direction, is not a vector quantity. Same for time. Time, as we all know, has an arrow of time which is moving from the past to the future. So it has a direction and it has a magnitude, all of us know. So again, time possesses both magnitude and direction, but yet it is not a vector again. Why? Because it do not follow the vector algebra. So you see, there are examples where we can pick up things which, in spite of having magnitude and direction, are not considered as vector, as they do not follow the vector algebra. Now let us discuss with one more quantity which is very important right at this point of time. Say its area. Now area, as we all know, is multiplication of length and breadth, or for a circle, which is given by a specific formula, as you all know. But area as a vector is treated something like this. So you have area, you have a length, you have a breadth. So you have a length, you have a breadth, and the area in magnitude accounts to A, L into B. Say for example, the value of L, which happens to be 2, value of B, which happens to be 3. So you say that the area is 2 into 3, which is 6 units. So now when I am talking about this kind of area, then the vector of the area is perpendicular to its plane. So the direction of area vector is always perpendicular to its plane. So this should be 90 degrees. So if you see, if I have a vector, I have an area like this, then I should have a direction like this. If I have a vector like this, an area like this, then I should have a area vector like this. So you see, in every case, the angle of the area vector is at right angle with the plane. Now, the direction. Many argue that why it is not that the area direction is directed like this. Well, this is based on the fact that it should be treated as an area, or the direction should be treated in such a way as in the area which you consider. Say you have a dimension like this, and you are considering this part of the area. So the direction will be directed from here. So you have area for this, and you are considering this part, the lower part, so the direction will be like this. So the direction is almost given on the basis of the fact which is utilized as area. So when you are utilizing the lower portion, you are considering the area direction right angle to that, and if you consider the upper portion, then you consider the area perpendicular to that. So that is what we are dealing with, the fundamental concept of vector and scalars. Now there is one more point which we need to understand, is the fact that I just said, if you remember, that there is no division allowed in vector. Now when we say that there is no division allowed in vector, we have a problem with a particular quantity which is called pressure. You see, pressure, as you all know, is force per unit area. And we have just learned that area is a vector, force is already a vector. So now this happens to be a division of two vectors, which we say is not permitted. So now we come to the introduction of another quantity which we called a tensor. Now what is a tensor actually? Tensor is having quantities having magnitude which will vary with choice of axis. So magnitude vary with choice of axis. Now a very good example of a tensor quantity is obviously pressure. And there are other quantities which we will learn very soon, like moment of inertia, where again the quantity is a tensor quantity. So a tensor is a magnitude which vary with the choice of axis. Now let us come to one more point here regarding a tensor. Now a tensor is operated on a particular mathematical operation which is quite difficult to understand at this point of time. But what you need to know is that when we take a consideration of tensor, we apply a particular mathematical operation on it and we give a rank to it. And if the rank is 0, then we call it a scalar. And if the rank varies from 1 to 4, we call it a vector. So that you have to know at this point of time, that a tensor is actually divided into two quantities, a scalar and the vector. And a tensor of rank 0 is what is called a scalar, and a tensor of rank 1 to 4 is what is called a vector. And primarily vector having magnitude and direction, but along with that it should follow vector algebra. And scalar, as it comes from the scale, it has only magnitude. So that's all about the concept of vector and scalar right now. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.